Welcome to LabMinutes.com. In this video, we will look at how a NAT and a Cisco router handle the embedded IP and the application payload. We're going to demonstrate this using two commonly used protocol, DNS and FTP. So in a DNS setup that we have here, we have a DNS server on the inside with the IP 96.32, and we're going to use the R2 as a DNS client that's sitting on the outside. On the DNS server, there's an A record that we created with the name dc.labminutes.com that gets natted to the IP 32.32, and that's again in the loopback IP of the switch number 1. Okay. Just to show you what we have set up so far in the router 1, we have a NAT created for the DNS server that the R2 is configured with. So the DNS server 96.32 is natted to an outside IP of 1.64. And on R2, we have R2 configured with the natted IP 1.64 as the DNS server with the LabMinutes.com domain name. It's just to do a quick test on that natted IP, we can ping successfully. Okay. Now just to show you what's going on, we're gonna run Wireshark on the DNS server, which is the laptop that I'm using right now. Okay, we're just going to look at the DNS packet. Okay, just going to have that running in the background. So also on switch number 1, which is sitting on the inside, it's also configured to point to the DNS server using the native IPs. 96.32. So from the switch 1, acting as also a DNS client, if you're trying to ping a dc.labminutes.com, so you can ping successfully and resolve to the correct IP 32.32, which is the internal IP, and we can see two packet capture in the Wireshark, the DNS request and DNS reply. We'll come back and take a look at that in a sec. Next, we're going to try exact same thing on R2. So ping dc.labminutes.com. Okay, we're seeing some packets coming in. Though so far it's no reply because it's IPv6 name resolution. Here a second. Oh, there you go. So the reply came through and it fails. Just take a quick look at why it's failing. You can see the request that was made by R2 asking for dc.labminutes.com, and the reply received was, let's see, it said it's 32.32, so that's the native IP of our emulated server on the inside, and that's incorrect. And the reason being, we have not configured NAT on R1. So let's go ahead and do that. We're going to do IP NAT inside source static with the internal DC IPs 32.32 natted to 1111 and .32. Okay. If you do show host on R2, right now it has the incorrect IP, so we're going to clear that. Okay, now that's gone. Let's try another ping and R2 from R2. There you go. Give it a second. Okay, you can see the ping succeeded this time. Okay, so let's see what's going on here with packet capture. Actually on R2 you can see this time it came back and resolved to the correct IP, which is the NAT IP 111.32. If we do show host, now it's showing up with the correct IP, and that's why the ping succeeded. So scroll back real quick to the top where we had the switch 1 sending a DNS request to our server, and you can see the query is asking for DC at LabMinutes.com, an A record. Since the request is coming from the inside, the DNS server reply with here's answer with the actual IP of the server, which is 172.16.32.32, and that is fine. We have already looked at a request coming in earlier from R2 that failed. So after we configure the NAT on the router, let's see. So since the capture was done on the server side, you can still see that the payload and the DNS reply IP still show up as 32.32, but clearly on R2 it was told that the name of the dc.labminutes.com is actually natted to 111.32, and the reason that happened because the DNS reply, once the request hits the server, the reply comes back through R1, and R1 knows that it's a DNS reply. Look at the payload, find the IP, look up the table, and found a match right here that we configure. So in the payload has the native IP 32.32, so it actually replaced that IP with the netted IP 111.32, and that's how R2 received the correct name resolution. Okay. So the R1 actually correct the IP in the DNS reply. Okay. So that's the DNS. Next we're going to move on to the FTP, which will get a little more interesting. So here with the FTP, I'm going to use my same machine that I used earlier for a DNS server to be an FTP server sitting on the outside. I have a separate machine running an FTP client. They'll be sitting on the inside with the IP 96.33. So first I need to move my machine here to the VLAN one on the outside and update the IP. So before I do that, let's clean up what we had. Okay, switch 1. So TFTP server, or FTP server rather, is going to have an IP of, let's see, 111. Let's say 64. And I do not need a gateway because we're going to pat everything coming from the inside to the interface, which we'll do in a second. So from R2, now it's on the same subnet as R2. Let me try to do a ping test real quick. Actually, let me change it to a different IP. 16. Okay, so now I can ping. Now the server is on the outside, and just to show you, I have the FTP client on the inside, 172.168.16.32.33. That is there as well. And we're gonna configure a port address translation on R1 for the client to go out to the outside. That would be external, just call it NAT. Permit, just keep it simple, IP any. You shouldn't be doing that in the production, but here's just for the lab, so that should be okay. IP NAT inside source list, NAT interface F01 overload. Alright, just to test from the inside, 16, ping no problem. And our pad is working. So ping gets padded to the interface IP. Okay, so I'm going to bring up my FTP server. First we're going to try FTP passive. So passive being everything will be initiated by the client side, both the control channel and the data channel. So I'm going to initiate an FTP passive from my other machine. And let's make sure we have the Wireshark running as well. So stop that. Start new one. Just going to look at the TCP packets. Okay. There you go. Actually, let me start that real quick. Okay, let's see. Okay, let's bring up our FTP screen. Initiate the client connection, port 21. You can see here on the output of the FTP Fazilla server, it's you can see that the connection came in with the password, username, password requests, and with the passive connections, with the server replying with the IPs and the data ports. Same thing here. If you look at the output of the FTP, you can see the username passwords show up in clear. So again, another reason why I shouldn't be using FTP in the production. Rather, I should use SFTP or equivalent with the encryption. Here the client request, passive mode, and the server reply with the IPs and the port for the data channel. Just to show you the calculation of the port and the data channel. That's 202 multiplied by 256 plus 82. So it should be 51794. Jump back to our Wireshark. Here's our data connection, and it matches up with our calculation 51794, and you can see the source IP it being 111.252, and that's initiated from the client side. That's a padded IP. Okay, everything works fine. on my other screen and my FTP client, it can see the directory of the FTP server. Now let's switch this to a active mode so you can see the different. Here on my client side, I'm going to change it to the active FTP. Let's start our Wireshark. Clear that, okay. Alright, again, succeeded with connection. Now I'm going to try to download the file from the client. There you go. You can see a login request successfully, and this time you can see the client is the one who informs the server which port the server who's being active needs to connect to bring up the data channel. Here it's 111.252. So, and again, the router has already fixed the payload. The IP that's embedded, the client IP is embedded on the payload and replaced with the NAT IP, and also the port. Okay, and you can see it retrieved the file. I have a file called ftp.txt. And just to look at the capture, right here is the data channel, and this time you can see the sent packet was sent first from the server side, 111.16, and that's the active FTP. Okay, so everything works fine with the default FTP port. The router has been programmed to support the default FTP port out of the box. The problem comes in when you start using a non-default FTP, and we can try it right now and see what's going to happen. So on the server side, setting, instead of 21, I'm going to change that to 2121 FTP port. I'm going to clear that, and again restart Wireshark. Okay, and on my client side, I'm going to change that and tell it to talk to 2121. Go. Connect. You can see right here the last message you see is can't open data connection. And if you look up a few lines above, you notice that before it was the NAT IP 1.252, but after we changed the port to non-default FTP port, you actually see the true client IP show up. So the router totally ignored the IP in the payload and did not fix that for us this time. Okay, so the client IPs being 96.33 shows up. Once the server is informed that it needs to talk to that IP, obviously the server has no route going back to that IP and the connection fails. You can see a bunch of resets packets. Okay, so fortunately the router has the capability to support a non-default FTP port. We just have to configure it. First we're going to configure IP access list standard, just called FTP, and we have to specify the IP of the server, FTP server, and here is 111.16. Next we're going to tell or apply that IPs to the NAT command, IP NAT service list right here. Specify access list, describe global addresses, list FTP, and you can see there's an option for FTP protocol with TCP port, and we changed our port to non-default 2121 and enter. With that in place, the router should now be informed to look for the port, FTP port, on 2121, so let's try that again. Clear all. Stop our Wireshark and restart. Let's clear that again. Okay, so we're still using active FTP here. And you can see now the IP shows up correctly. And the connection succeeded. And I can certainly try to download that file again on my client, on my other machine. And you can see here the file was retrieved successfully. And this time because the server knows the correct IP that needs to talk to. Okay, this usually becomes a problem when you do a active FTP, because it's for the client that's behind the NAT, and if the IP in the payload does not get translated properly, then it will become an issue. So usually if you do a passive FTP on a client that's behind the NAT, that would not become an issue because the client is the one always initiate the connection to a server. And again, to prove that, we can delete that command we did, clear it. We can certainly try to change the FTP back to passive mode. And on my client machine, I'm going to change that to FTP passive again. Quick connect. Download the file. And you can see everything works just fine with the retrieve succeeded. And that's because we are doing passive mode, and the server is the one that informs the client which port to connect, an IP to connect, and the client connects from the inside behind the NAT. Okay, we will show IP NAT translate on R01. You can see the control channel with 2121, and you can see the data channel. And if you look at here, you should see it, port 51803. It's right here, which is the same connection that we're looking at. And the passive mode worked just fine. Okay, so again, thank you for watching LabMinutes.com, and I'll see you guys in the next video.